Welcome to Spring LIB.
Hello. We have to calculate the angle between two vectors and then find the vector which is perpendicular to the first vector. So the first vector is vector u with the coordinates of square root of 2 over 2, 1, 0. And the second vector is vector v, which is 0, square root of 2 over 2, negative 1. So first let's calculate cosine of alpha, which is the angle between vectors u and v. So the scalar multiplication of these vectors equals to the length of each vector multiplied by the cosine of the angle between these two vectors. So therefore, cosine of the angle equals to the vector multiplication divided by the length of each vector. So let's first calculate scalar multiplication, scalar product. So it equals to, so we basically have to multiply coordinates. So it equals to square root of 2 over 2 multiplied by 0 plus 1 multiplied by square root of 2 over 2 plus 0 multiplied by minus 1, which is square root of 2 over 2. So now let's find the length of each vector. So the length of vector u is square root of 2 over 2 squared plus 1 squared plus 0 squared, which is square root of 3 over 2. And the length of vector v is square root of 2 over 2 squared plus minus 1 squared, which is also square root of 3 2s. So now let's calculate the cosine. So cosine of the angle equals to square root of 2 over 2 divided by square root of 3 over 2 multiplied by square root over 3 over 2. So which equals to square root of 2 over 3. So this is a cosine of the angle between these two vectors. So now let's find the vector which is perpendicular to the first one. So now we have to find the vector w, which is perpendicular to vector u. Again, the vector u has coordinates of square root of 2 over 2, 1, 0. So basically cosine of beta, which is angle between these two vectors, is 0 when the vector multiplication between these two vectors is 0. So basically, if we have a vector with coordinates w1, w2, w3, we have to meet the following condition. So u1 multiplied by w1 plus u2 multiplied by w2 plus u3 multiplied by w3 equals to 0. So u3 equals to 0. And these guys, the other components of the first vector are non-zero. Therefore, to meet this condition, w1 and w2 are 0, and w3 can be any number. So that's why any vector which looks like 0, 0, w3 is perpendicular to vector v.